Welcome back everyone. It has apparently been 3 years since I last updated this tutorial, which was mainly because I lost all my data due to a hard disk crash, and I didn't back up stuff and didn't use source control properly, so everything was gone, which means that the tutorial code, the Unity scenes, and all recording material were gone. Which was, yeah, it was a bit sad, but not really the end of the world for me. Um, all it did was basically it prevented me from creating the next tutorial. Since then I've been quite busy doing other things and basically left it on a super low priority for whenever I would have too much time on my hands. And that basically happens never. That's because I've been doing a lot in the meanwhile. I completed my studies, been exploring other areas in programming, game development, and most importantly, I've been fortunate enough to work on the Age of Empires series. And that series also happens to be the um, yeah, basically where my interest in game development and programming originated from. Now I might also be doing a playthrough of the campaigns in the future because I promised myself to allocate some time to play the game after release. And now I thought that it might also be fun to record it and restart this channel a bit. And then I remembered that I still had a rough version of the third tutorial lying around. So I'm adding it to this update video. It's not really a complete tutorial, and it misses some parts, but it should be good enough to at least get reflections working in the scene. And if you're really good, you could also get refractions working. I'm not really planning to continue the tutorial series unless there's like a lot of requests to do it, but yeah, it would be quite a bit of work for me to set up all the tutorial code, the Unity scenes, and recording stuff to do the tutorial basically. Now I might be doing some other tutorials in the future that might be easier to do, and maybe do it in smaller sets or maybe less in depth. But that's yeah, I'll see. Now, as you probably have seen, we've done some yeah, some recordings of work that I did in the past years. Mainly because I thought that you probably would like to see something while I was talking about the update. I might be doing some videos on explaining what they're about actually, if people are interested. And yeah, I guess that's all, and we can start with the actual draft version of the tutorial. So the first thing I talk about is Specular light and diffuse light. Last tutorial I showed you how to implement diffuse light, but I did not go in depth with a visualization of what it actually was. So now I'm going to show you that, and also what specular light is in this Unity scene. This is how the diffuse light looks like. As you can see, it gives an approximation of how much light is reflected if it hit the surface with a blue arrow normal. To make it even more clear, I'm going to show you how much light will bounce off in every direction with a drawn line. And it would look like this. Next thing that I'll explain will be the specular light. For that we need a vector that's the reflected direction of the light, and we need an eye point. Oh. Which will be this point. Now, we take a dot product of those 2 points, the point and the reflected vector, and we get another vector. And this vector will behave similar to the other dot products, also in a circle. Now, to get an approximation of the specular light, we need to take the result to a power of how shiny the surface is. Yep. As you can see now, it becomes more of an ellipse now. Now, if we add that to a diffuse light, we get a rough approximation of how our light affects shiny surfaces. And that will look a bit like this. Let me change it a bit. So now what we can see here is that this part will reflect more light than the other parts. And that's basically what specular light is. And if we increase the shininess of the object, so let's make it a bit more insane. We get an even sharper point. To get it working in our code, we need to modify the spheres and give them some variables that they can use for specular lighting. Every sphere now needs a shininess value and a value whether it needs to use a light's color or its own color. This is because things like metal reflect their own color and our skin the light's color. And that's because we as humans have some oil on our skins which reflect the light, and metal usually does not. So with this bool we can fake that effect. We also need a way to reflect a vector on a normal, which is actually quite simple, and I'll explain that with a Unity scene again. To reflect a vector on a normal, we need to dot the vector with the normal. Then we need to multiply the result with the normal. This will give us this vector. And all that's left is multiplying this vector by 2. And then we need to subtract this vector from the incoming vector, which will result in a reflected vector. And that's all we have to do. So the last thing to do is adding the data to the spheres and applying the specular color on top of the diffuse. So here we add the data, and here we apply the specular. We calculate it over here, and we apply it on top of the diffuse, if there is any specular, or else we just use the diffuse. Now there is now this is actually not a valid light system, as there gets more light out than is put in. But it's fast, and I don't think we need something better than this right now. And we can always look at implementing a better light system later on. And this is the result. As you can see on the purple sphere, it works nicely, and it's a bit harder to see on the white one. But if you move over here, you'll be able to see a specular highlight. There it is. Our next thing will be adding reflection. We already know how to reflect a vector on a normal, so it's rather simple to implement. First we need to add a bool to the spheres to determine whether it reflects or not. Then we are going to add another trace function, so we can cast a new ray whenever we reflect off a mirror. Then, as last, we update the data so that the left sphere is actually a mirror, and then we check whenever we hit a sphere whether it's reflective, and if it is, then we cast a new ray which is reflected. And since it will call this function again, it will continuously, recursively go through this function until it hits its final point, and then it does the light calculations. And this will result in working reflections. As you can see, there it is. We got one sphere that reflects every ray and acts like a mirror. Pretty cool, huh? Okay, so how this looks if we visualize it. We shoot our primary ray, which hits a mirror object. Then we reflect that vector, that ray, onto this object, and we shoot another ray towards that hits another primitive in the scene, which is not reflective. So there we calculate the diffuse lighting by shooting a ray towards the light, and this way we obtain the final color of this pixel. And if we finish it, there we have it. The image rendered the mirror, which is on this side, which reflected both of the balls. It looks pretty good. Now we visualize what happens if a ray hits a glass object. So it looks like a kinda a big mess of rays basically. But let me explain what exactly happens. So our first ray hits our glass ball. And from there it will shoot another ray, which is a reflection, and a refracted ray. That refracted ray then refracts another time, and then finally hits our diffuse object. Now, it also reflects another time, like an internal reflection does. Now, it hits the glass ball again, refracts another time, but also reflects another time. And the same happens over here. It reflects and refracts another time before it leaves the ray trace. And the final image will be rendered. And now you can see the image correctly rendered the glass ball, which basically refracts rays and hits different objects. So you can see this sphere on this side of the ball, this sphere on this side of the ball, and even the mirrored sphere on this side of the ball. So a ray enters here, leaves the ball over here, hits the mirror, then hits the object. And that's where the beauty of ray tracing comes, as the recursion will basically solve that for us. Now, to make this working in the code, I changed around some things. First I added a material type, which gets rid of all the bools that we were using, and I added a refraction, which is just a float of how much the object refracts. I also added a function to refract. Now here I updated the data, so it contained a glass object next to the mirror object, and I made sure that it was being checked for the glass, and updated the mirror part as well. So basically here I do the regular stuff, calculate the hit point, then I use a Fresnel calculation to calculate how much is being reflected and how much is being refracted. With this I can calculate how much the effect of the refracted part of the ray affects the final color and how much the reflected part of the ray affects the final color, which is a simple calculation. Now, so basically as soon as I hit an object, I create one refraction ray, which I trace then, and one reflection ray, which I also trace. And I will keep doing this until I hit the maximum depth, which I set to 5. If I did not add this, there would be a big possibility that our rays would be bouncing around forever, which is something you do not in general want. And I also changed our ray sphere intersection a bit, because our current ray sphere intersection did not allow for rays to start inside the sphere. Now with refraction, this will be the case. So to work around that, I do a check. If I'm inside this sphere, I basically just calculate the distance to the point. And that's basically our new length. And that's all you need to do to make it work with the ray being inside the sphere. And the result is this scene, which has a beautiful glass object being rendered with very low FPS. I think we're at 7 FPS or maybe even less. Yeah. We'll be optimizing this in the near future, but first we're gonna do something slightly different, which allows us to use awesome other primitives.